This is SpaceTime, Series 27, Episode 13, for broadcast on the 29th of January 2024. Coming up on SpaceTime, NASA shuts down its Mars Ingenuity Helicopter mission. A mysterious monster discovered in an ancient globular cluster. And could diamonds be driving Neptune and Uranus's magnetic fields? All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
NASA has been forced to end its history-making Mars Ingenuity Helicopter mission on the Red Planet. The decision to end the mission was taken by the team at NASA's Jet Propulsion Laboratory in Pasadena, California, after images showed damage to one of the rotorcopter's blades. The problems began when NASA suddenly lost contact with Ingenuity during its 72nd flight on January the 18th. The mission was designed to simply be a quick pop-up vertical flight in order to check out the helicopter systems following an unplanned early landing during its previous flight. Data sent by Ingenuity to the Perseverance rover, which then relays the telemetry back to Earth, indicated that the tissue box-sized drone successfully climbed to its assigned maximum altitude of 12 meters. It then hovered there for 4.5 seconds before starting its descent at a velocity of 1 meter per second. However, during the descent, when it was still 1 meter off the ground, the 1.8 kilogram helicopter suddenly lost contact with the rover. Now, Ingenuity had lost communications before, usually when direct line of sight signals to the rover were blocked by terrain. Mission managers were able to re-establish contact with the rover the following day after instructing Perseverance to undertake long-duration listening sessions. Once contact had been re-established, more information about the flight was then relayed back to ground controllers at JPL. Now, at this stage, the cause of the communications dropout is still being investigated. Also, mission managers still don't know why the previous mission ended abruptly. But when they reviewed the latest data, they found that one or more of the rotor blades had sustained damage during the landing and was no longer capable of flight. Right now, Ingenuity remains upright on the ground and in communication with mission managers. The helicopter was originally sent to Mars with Perseverance as a technology demonstrator. It was designed to perform just 5 experimental test flights over 30 days to see if it was even possible to fly in the ultra-thin Martian atmosphere. Ingenuity had landed on Mars on February the 18th, 2021, attached to the undercarriage of the car-sized Perseverance rover. The tiny helicopter's historic first flight off the Martian surface was on April the 19th, proving once and for all that powered, controlled flight on Mars was possible. After notching up another 4 flights, Ingenuity embarked on a new mission as an operations demonstration, serving as an aerial scout for the Perseverance rover, finding interesting features ahead of the rover and warning of any dangerous terrain best avoided. Now, almost 3 years and 1,000 Martian days later, Ingenuity has performed 72 flights. That means it's flown more than 14 times further and 33 times longer than originally planned, logging in more than 2 hours of overall flight time in the process. Over its extended mission, Ingenuity was upgraded on several occasions, giving it the ability to autonomously choose landing sites in treacherous terrain, deal with a dead sensor, and clean itself after dust storms. It operated from 48 different landing sites, performed 3 emergency landings, and it survived a frigid Martian winter. But there were problems. Ingenuity was unable to power its heaters throughout the night during the coldest parts of the Martian winter, resulting in the flight computer periodically freezing and resetting. These power brownouts required team managers to redesign Ingenuity's winter operations in order to keep flying. With final flight operations now concluded, mission managers will perform final tests on the helicopter systems and download the remaining imagery and data in Ingenuity's onboard memory. Sadly, the Perseverance rover is currently too far away to attempt to get an image of the helicopter at its final resting place. NASA Administrator Bill Nelson says the helicopter's performance and resilience in the harsh Martian environment greatly exceeded expectations.
It is bittersweet that I must announce that Ingenuity, the little helicopter that could, and it kept saying, I think I can, I think I can. Well, it has now taken its last flight on Mars. As it was coming down for a landing, at least one of its carbon fiber rotor blades was damaged. We're investigating the possibility that the blade struck the ground. It's a special fiber with a special contour. That little helicopter could fly in a 1% atmosphere, not 100% atmosphere like we have on Earth. It cut through a 1% atmosphere and was able to fly. And what Ingenuity accomplished far exceeds what we thought possible. Almost 3 years ago, the helicopter made its first flight on the planet Mars.
Altimeter data confirms that Ingenuity has performed its first flight.
And living up to its name, Ingenuity made history as the first aircraft to make a powered, controlled flight on another planet. But then it flew farther and higher than we ever thought possible. And what started as a technology demonstration with plans for only up to 5 flights has now completed a remarkable 72 flights on Mars. And the innovation doesn't stop here. It acted as a scout for the Perseverance rover. It would go and check out sites. Ingenuity demonstrated how flight can enhance operational missions, and it's helping us in the search for life on Mars. And like the Wright brothers, what they did back here on Earth at the early part of the last century, Ingenuity has paved the way for future flight in our solar system. And it's leading the way for smarter, safer human missions to Mars and beyond. NASA proved once again that with relentless determination and the power of America's best minds, anything is possible. That's what we try to do at NASA, make the impossible possible. And so, thank you, Ingenuity.
That's Bill Nelson, the administrator of NASA. And this is SpaceTime. Still to come, discovery of a mystery monster in the heart of an ancient globular cluster. And a new study suggests that diamonds could be driving the magnetic fields of the ice giants Neptune and Uranus. All that and more still to come on SpaceTime. Astronomers may have detected a mysterious monster in the heart of 47 Tucanae, one of the most famous globular clusters in the sky. The object, reported in the Astrophysical Journal, could be either a rarely seen and long sought-after intermediate mass black hole or a pulsar, a rapidly spinning neutron star. It was picked up as scientists were undertaking the most sensitive and detailed radio image ever undertaken of this spectacular globular cluster. Globular clusters are ancient stellar spheres containing thousands to millions of tightly packed stars. They're thought to be either the relic nuclei of dwarf galaxies that have lost the rest of their stars during galactic mergers, or they could be families of stars which were all born together at the same time in the same molecular gas and dust cloud. Globular clusters tend to hover around the edges of galaxies. The Milky Way is thought to have at least 150 of them. 47 Tucanae, which is also known as NGC 104, is located around 50,000 light-years away in the direction of the constellation Tucanae. It's the second brightest globular cluster in the night sky after Omega Centauri. One of the study's authors, Dr. Arash Baramian, from the Curtin University node of the International Center for Radio Astronomy Research, says 47 Tucanae is one of the most massive globular clusters in the galaxy. It has over 1 million stars and a very bright, dense central core. The ultra-sensitive image of the cluster was created from more than 450 hours of observations using the CSIRO's Australia Telescope Compact Array near Narrabri in northwestern New South Wales. Brahmian says 47 Tucanae can be seen with the unaided eye and was first catalogued by astronomers back in the 1750s. But imaging it in such great detail has now allowed astronomers to discover an incredibly faint radio signal at the centre of the cluster that had never been detected previously. This signal suggests that 47 Tucanae contains either an intermediate mass black hole or a pulsar. Intermediate mass black holes are extremely rare. They have masses somewhere between that of a supermassive black hole, of the type found at the centres of galaxies, and the stellar mass black hole, which are created by collapsed stars. We see lots of both stellar mass black holes and supermassive black holes, but finding intermediate-sized black holes, something that fits between the two, is extremely rare. And while intermediate black holes are thought to exist inside globular clusters, there's never been a clear detection of one. Now, if the signal turns out to be an intermediate-sized black hole, it would be a highly significant discovery and the first ever radio detection of one inside a cluster. Now, the second possible source for the signal is a pulsar, a rotating neutron star that emits radio waves. Neutron stars are the collapsed stellar cores of stars far more massive than the Sun. They spin incredibly fast, producing a beam of energy that shines out across the universe like a lighthouse beacon. Baramian says a pulsar this close to a cluster center is also scientifically interesting because it could be used to search for a central black hole that's yet to be detected.
47 Tucanae is one of the brightest globular clusters in the night sky, and it's partially because it's very large compared to other globular clusters, and partially because it's relatively close when we consider galactic distance. Now, what we have done is we have used CSIRO's Australia Telescope Compact Array to look at this cluster and push the sensitivity of the observatory to its limits. We looked at it for 450 hours of observations. We looked at it. And what has happened, this allowed us to make the deepest radio image ever made of a globular cluster. Now, the reason this is exciting is because globular clusters are among the oldest parts of our galaxy. They were formed when the galaxy was very young. So we are talking about 10 billion years old, roughly, in age. So what we are looking at is this dense collection of stars, that some stars that were very massive have already gone through the stages of stellar life and turned into stellar remnants. Things like black holes or neutron stars, which are dense remnants of stars. And now those remnants are still moving around in the globular cluster and occasionally interact with other stars that are around. And these interactions create energetic signatures, either X-ray emission or radio emission that we can observe. So when we observe with this amount of sensitivity, with this much effort, and push things to make the deepest image, we start to capture some of the things that have been hidden and we have never captured before. So now we see the deepest image. We are starting to see neutron stars and black holes that have never been seen before in this cluster. And at the center of the cluster, we notice a very faint source at the center of the globular cluster. Now, this was exciting for multiple reasons, because typically at the center of these globular clusters is where the density is the highest. This is where you expect some more exotic elements of the cluster to be. For example, one of the things that have been speculated for a long time to be present at the center of the globular cluster is an intermediate mass black hole. So what that is, when we look at the black holes in the universe, we see two main groups. We see stellar mass black holes. These are black holes that are formed when stars die, heavy stars die, and they turn into stellar mass black holes, a few times more massive than our sun. At the other end, we have supermassive black holes. These are black holes at the center of the galaxy. They are millions of times heavier than the sun. So these are the two groups that we have observed. We have measured their masses. We know of their existence. However, this is kind of like, the situation is kind of like going into a village and you see toddlers and you see adults, but you don't see any teenagers. But you infer that there's got to be some teenagers, you just haven't seen them. Maybe they are at the playground, but you haven't seen. This is the kind of situation with intermediate mass black holes. We have seen the stellar mass black holes. We have seen the supermassive black holes. There are a few intermediate mass black hole candidates that have been identified in the cosmos. But one of the places that people have speculated these intermediate mass black holes should be is center of globular clusters. And that is one of the exciting interpretations of that faint signal that we have seen in the center of our globular cluster. So that's very exciting. If true, it would it would allow us to understand more about the black holes and how they grow, how they evolve. The other interpretation of this signal is that it could be a pulsar. So neutron stars are dense remnants of stars that explode. These are very dense. We're talking densities that are tens of thousands of times. So if you have a spoonful of matter from a neutron star, that matter that will be heavier 10,000 times, roughly more than Sydney Opera House. So that's the density we are talking about here. So neutron stars, some of them rotate very rapidly. This rapid rotation makes them appear pulsating from our point of view. So the other interpretation is that this signal we have seen at the center of the globular cluster could be a pulsar. That is also exciting because pulsars are amongst some of the most precise clocks in the universe. So by tracking, it is really a pulsar, which follow-up studies may confirm, then allows us to understand the dynamics at the center of the cluster with some of the most precise clocks in the universe. So either of the two interpretations are very exciting and allow us to understand how globular clusters have evolved, stars in the galaxy have evolved to get here. The other exciting factor about this discovery and study was the fact that we have pushed the sensitivity of our current generation of observatories to their limit. And this is exciting as we prepare for the next generation of observatories, such as Square Kilometre Array, which is currently being built in Western Australia. As we learn about the techniques that we are developing, as we learn about the challenges that we may face as we accumulate this much data and we try to make sense of it, these kind of studies allow us to be more efficient and harness all of the science that we can capture from the next generation of observatories.
When you look at the density of the material around the center of the globular cluster, are you able to differentiate stars or other objects orbiting around the central point? I guess where I'm getting at there is any idea of the mass of the object.
We cannot get the mass dynamically. What I mean dynamically is, for example, sometimes when we look at binary star systems, we can easily apply Newtonian mechanics at the orbit and say, okay, these have to be the masses. However, there are other indirect methods to infer the mass. For example, we can look at the brightness of it and we say, well, if it is this class of object, based on how much energy it's releasing, this is the mass it can have. So under that interpretation, under these methods, if this is a black hole, we expect its mass to be around a few hundred times more massive than the sun.
See, that's important because this really does put us in those teenage years that we've been looking forward to.
So it's the range that we consider intermediate. It's not a clear-cut definition, but roughly we would say a few hundred, so around 200 is where stellar evolution models cannot really predict black holes of that mass, around 100, 200 roughly, all the way to around 100,000. That's the range that really is hard to find black holes in that range. Now, at the upper end, like a few 100,000, a few 10,000, there are now a few good candidates that have been found at the center of what we call dwarf galaxies. These are galaxies that are not really the size of Milky Way or Andromeda. They're very tiny, but they are in the same system of galaxies, for example. And some of them seem to host black holes at the center that may be 10,000 times more massive than the sun or 100,000 times more massive than the sun. So in that context, when we look at it, finding a black hole that is only a few hundred solar mass at the center of a cluster, it is quite surprising and interesting because we're saying that we are finding this awkward zone that is just more massive than stellar mass black holes, but at the very low end of the intermediate mass black hole spectrum. So it is exciting. It tells us, it also reveals, because of its low mass, if it's a common pattern among other globular clusters, it is telling us that because of this low mass, that's why we haven't found it in previous efforts, because they're so light that you need so much observations to actually detect them.
And of course, the other problem is has the universe been around long enough for a stellar mass black hole to grow into a supermassive black hole, assuming they start out the same way?
Yeah, precisely. Yes, that is one of the problems that the growth theory, as it's referred to, which is stellar mass black holes merge and become larger and larger and turn into supermassive black holes. Is that actually a viable theory given the age of the universe? Yeah, precisely. Yes, that's a problem.
When you look at this globular cluster and you look at the stars within it, are they made out of the same material as the other stars within that part of the Milky Way galaxy? In other words, do they all have the same sort of metallicity, or are we seeing something which may once have started out as the core of a different galaxy?
Oh, that's a fantastic question. So for 47 Tucanae, what we see is metallicity is comparatively with, like, for example, other parts of the galaxy around it, it is a bit more metal poor and that is expected because we expect stars in the 47 Tucanae to have formed a lot earlier. So you expect them to be older. So that's what we are seeing. However, what you said about being core of other galaxies, that applies to a couple of globular clusters in our galaxy, that their distribution of elements, their metallicity, and sometimes even their shape is a bit unusual compared to other globular clusters in our galaxy. And there is this ongoing discussion and study if some of them may have been small dwarf galaxies that interacted with our galaxy and got stripped of some of their stars and became what looks like a globular cluster, but they weren't a globular cluster from the beginning. But for 47 Tucanae, we're pretty sure they are the stars in that cluster formed as part of the Milky Way.
Where is your research going to take you next?
So there are two exciting bits that we are really keen to follow. First is that the amount of data we have collected on 47 Tucanae with this project, there's still a lot of exciting stuff to explore and analyze. We made the first image, which is the deepest image, and the most exciting thing was the source in the center. There are a lot of other signals in the cluster that are likely to be neutron stars or other types of less exotic stellar objects that we are going to explore and understand. And then after that, my focus is now on understanding the population of black holes in our galaxy. I'm trying to understand how many stellar mass black holes are in our galaxy. What fraction of them are we really able to observe? Because black holes are notoriously hard to observe because they don't have any light and they are only observed when they interact with other stars or the light of other stars. So trying to connect the theoretical expectation of population of black holes to what is actually observed is one of my goals in the next few years.
That's Dr. Arash Baramian from the Curtin University node of the International Center for Radio Astronomy Research. And this is SpaceTime. Still to come, could diamonds be driving Neptune and Uranus's magnetic fields? And later in the science report, NASA's new experimental supersonic aircraft specifically designed not to generate a sonic boom. All that and more still to come on SpaceTime. A new study suggests that diamond rain in the dense atmospheres of the ice giants Uranus and Neptune could be driving these distant worlds' magnetic fields. The findings, reported in the journal Nature Astronomy, are based on new resolutions to long-standing issues about the temperature and pressure conditions under which diamonds form from short-lived hydrocarbons, such as those expected to be found inside these ice giants. The authors used sophisticated computer modelling to describe the internal conditions deep inside the atmospheres of both Uranus and Neptune, and then monitor how small samples of planetary building blocks behave and rearrange under these extreme conditions. Previous modelling had already provided scientists with a fairly rough idea of the processes by which diamonds form from short-lived hydrocarbon molecules inside ice giant interiors. But different lab techniques have been yielding varying results, making it challenging to pin down the exact depth at which this process occurs. The main debate centered on experiments that compress hydrocarbons to bring them to pressure extremes, and the experiments that create these conditions by hitting samples with high-speed projectiles mimicking a meteor impact. Instead, the authors of this study used an X-ray laser capable of generating ultra-short flashes 27,000 times per second. This would then hit a compressed sample of polystyrene with ultra-short X-ray flashes, producing a sort of Goldilocks method to resolve the tension between the two earlier approaches. They found that diamond formation was observed under pressures ranging from 19 to 27 gigapascals and above 2,500 Kelvin. Now, what all that means is that diamond rains form at shallower depths than previously thought. And because it's denser than the surrounding material, it sinks deeper, providing an additional heat source, which could then drive convection in the ice layer, and it's that which could be contributing to these planets' complex magnetic fields. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that as little as a single degree in average global temperature increase could shorten your life by as much as half a year. A report in the journal PLOS One shows that just 1 degree Celsius of warming may cost an average of 6 months off the average human lifespan, with women and people in developing nations facing the most significant consequences. The findings are based on studies of data from 191 different countries. The study looked at how direct factors such as storms and indicative factors such as mental illness all contribute to an overall lowering effect on global human life expectancies. NASA has unveiled a new experimental supersonic aircraft specifically designed not to generate a sonic boom. The technological advances made to the aircraft, known as the X-59, reduce the usual ear-splitting crack of the sonic boom to a more quiet thump as the aircraft breaks the sound barrier. The key is a new ultra-thin tapered nose design, which breaks up the shock waves traditionally created when an aircraft traverses the sound barrier. But the configuration means the cockpit's located almost halfway down the length of the aircraft, and it does not have a forward-facing window. Instead, the X-59 team developed an external vision system using a series of high-resolution cameras, which are then feeding a set of 4K monitors in the cockpit. The aircraft also uses a top-of-fuselage-mounted engine, resulting in a smoother belly to help keep shock waves from merging behind the aircraft and causing a sonic boom. The aircraft was unveiled at Lockheed's secret Skunk Works facility in the Mojave Desert. NASA Project Integration Manager Peter Cohen says the X-59 will undertake its maiden flight later this year before attempting its first quiet supersonic transit. The test flights will initially occur at the Skunk Works before transferring down the road to NASA's Armstrong Flight Research Center at the Edwards Air Force Base. NASA hopes the new supersonic transport could revolutionize air travel, paving the way for a new generation of commercial aircraft that can travel faster than sound. Of course, the Concorde did all this during the 1960s and 70s, but it left a sonic boom that resulted in governments banning it from achieving supersonic speeds over land. It therefore became restricted to supersonic flight only on transatlantic journeys. A new study has confirmed that most dogs love watching TV. And the findings by researchers from the University of Wisconsin-Madison also show that man's best friends do have their favorite shows. The 2-year study, reported in the Applied Animal Behavior Science Journal, was designed to learn what video content engaged pooches the most. 1,600 dog owners from the United States, Canada, Europe, the UK, Australia and New Zealand were asked to fill out a questionnaire looking at how their dog behaved when the TV was on. And it seems our furry friends love cartoons with animals in them best of all, and no surprises for guessing they especially love those with dogs in them. They also like other nature documentaries, anything with animals in them, again, especially those with dogs in them. But interestingly, they find shows with humans fairly boring. A new study has found that 42% of Americans claim they've felt a paranormal presence in their home. 37% claim they've heard unexplained sounds such as footsteps or voices, and 19% say they've actually seen apparitions or ghostly figures. The study also shows that 49% of strange experiences, paranormal experiences that is, happen in the bedroom. 26% in the living room, 23% in the kitchen, 21% in the hallway or on the stairs, but only 12% in the basement. Some 19% of those surveyed prayed right after the experience happened. The research also found that 1 in 10 of the Americans surveyed have used a Ouija board in their home, and of those, 42% said they'd never do it again. Amazingly, 7 out of the 1,017 people surveyed didn't stick around to figure out what had happened, and actually moved away from their home after the experience. Over 40% said their community has a long history of local ghost stories, and more than half believe the stories are real. But Tim Mendham from Australian Skeptics says those funding this study are advising people to try something else first before resorting to an exorcist.
If anyone in an old home knows that the thing creaks and it settles and all sorts of noises are being made. This was a study done of about 1,000 people in America, asking them a range of questions. Do you notice sounds and things? Do you notice any strange occurrences? Where do you notice them? What reactions do people have to them? And is your house haunted? So what they found out was that about 42% of people felt there was a paranormal presence in their home, and 16% thought that the house was haunted. 37% had unexplained sounds and things, and 19% sort of had seen apparitions. Quite an extensive little survey, actually. One of the issues they point out is that a lot of these phenomena might be caused by the house, right? Not by being haunted, but if it's an old house, you've got things coming adrift, etc. You've got the fiberboard fascia of the house or something is creaking a bit, it's coming loose, it's letting wind in, windows need rattling, all sorts of things. One of the points they made was that some people reported stationary objects moving, such as doors and windows. They didn't thought were stationary objects, actually, that they can move. That's part of the principle of those things. But yeah, the interesting thing about the survey is it's actually done by a home repair company. Now, the survey might be legit, but the reason, the solutions they offer is get your house fixed. I think it's a very inventive one, actually, this particular survey.
That's great.
I think it's lovely. They actually commissioned a survey, so they might have had this in mind all along. But the eerie encounters that people have, the interesting thing is certain rooms are eerier than others, and obviously the room which is the eeriest and has the most paranormal events is the bedroom. Now, what do you do in the bedroom?
Well, there's the ghost under the bed. There's always a monster under the bed, isn't there?
Yeah, you sleep. And it's dark, and hopefully it's dark. You turn the lights off and go to sleep. So naturally, that is a room that lends itself to spooky feelings, especially if you're only half awake and you're sort of in a dream state, etc. And you're more likely to see a ghost in a bedroom than you would, say, in a kitchen, where it's pretty bright. Apart from the knives and things around there, you're fairly safe from ghosts. But all sorts of these things. It's quite fascinating little survey, but saying that in America, there's a lot more older houses, and perhaps they are where I live, which is a newish sort of suburb where the houses might range from average age to be 50 years old, say. And they're suggesting that this is a factor in the sort of haunting and paranormal things that people report. And of course, some old houses are pretty spooky just in their own right. If you're seeing noises, if you're seeing visions and things, go talk to your home repair company. Don't exorcise, renovate. Might be the best solution.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.